Good afternoon, everybody. Today is Tuesday, April the 30th, and we're going to get into reviewing for our chemistry final exam. So I know many of you guys are excited and you're also nervous about preparing for your chemistry exam. So what I've got for you guys is going to give you all a review based on what you need to know for your upcoming chemistry final, okay? So what I'm going to do today, I'm going to go through a couple of practice problems from the very beginning for General Chemistry 1. So many of you guys that are actually in General Chemistry, you need to be reviewing. I know many of my students are preparing for their final exam as the semester comes to an end. I also know that many of you guys are preparing for your AP final exam as well, which will take place next week. So I figure it will be best if we go from the very top and work ourselves down to the very end starting today. If you have any special requests, I recommend that you guys come and either DM me or go to my very last video and just post your questions there. Okay. So if you guys are ready to start, I'm ready to get into it. All right. So let's go ahead and go. All right. So right here, what you see, I'm going to zoom in a little bit so you guys can see the questions. Okay. And what it deals with are measurements. So, when we first start teaching chemistry, there's always a question that deals with scientific notations, significant figures, all of that fun stuff. And I know many students do not like this part, but it's something that you got to know. Okay. Unfortunately, what you don't like will most of the time be on your final exam. So if we take a look at this very first question right here, number 3, it says the measurement 0 point, and I'm going to zoom in a little bit more so you all can see the question. Okay, there it is right there. The measurement 0.0000065 is expressed using scientific notation. So, Malia, you said E, that is incorrect because we said express the answer in scientific notation. So keep in mind, you got to read the question and follow the directions, okay? So it is not E. That's okay. All right, so someone said D. Well, D is also not the correct answer. No problem, Malia, no problem. Ania said B, and you are correct. Here's how you know what you're working with. First off, if you count these zeros here, there's 1, 2, 3, 4, 5, 6 zeros. Because there are 6 zeros, that tells me that's going to be my exponent. Whenever you have zeros leading right here, times 10 to the whatever, your exponent will be negative, whatever the number of zeros that you have. Okay? So, what you're going to do is keep that in mind. Count the zeros that come before it, put that in your exponent, and put that as a negative number, okay, for your exponents. That's just a quick little tip for those types of examples. Now, when you get to these final exam questions, something else I want you guys to remember. Hello, Sweet Turkey Barbecue. Thank you. Alabama in the house. Yes, 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 yes. You're welcome, Landon. I appreciate that. So, what you guys got to remember also that when you're taking a final exam, you have to time yourself. If your exams normally take you an hour to do it, remember during the final exam time, it may take you 2 hours to do it. Okay? So, today's topic is based on doing a final exam review for AP chemistry students as well as General Chemistry 1. All right, so now look at the next problem. It says, which of the following examples illustrates a number that is correctly rounded to 3 significant figures? All right, what you have to remember, guys, is that if you know the rules, you're looking to see which one of these numbers right here has the correct number of significant digits in terms of 3. So the numbers that I underlined in blue, those are what we're focusing on, okay? So if you look at your answer choices, You have to find the answer that has three significant digits. It really doesn't matter what's here, but you do want to look at what's there, okay, what I'm circling. So I see that Malaya actually said E. P said E. All right, so we got some E's coming up, and you guys are correct. E is correct. If we look at this first number, 4.054 has four significant digits. So we know that that's not the correct answer. If we look at the second one, letter B, these two numbers here, the 4 and the 0, only give us two significant digits. The 0 that comes before the 4 does not count. Only the 4 and then any numbers that come after it do. 103.7 also has four significant digits. 109, 500, that gives us six significant digits. So the only answer that has three significant digits is the 20.0. Now, let's erase that, and let's take a look now at number 5. Number 5. So for number 5, they want to know which of these answers has the correct number of significant figures. So now let me zoom in so you all can see the problem a little closer, okay? Which one of these final answers here has the correct number of significant digits? So here's how you're going to answer this question. You always look at the number that you start with, okay? Not the conversion factor. So let me underline the conversion factor. This is your conversion factor here. If you're trying to convert a number to another thing, you do not use what I am highlighting here, which are your conversion factors. You don't use that to give the final answer. Instead, you look at the starting number to decide that answer, okay? So right here, we've got four significant digits in letter A, but our answer does not have four significant digits. In letter B, we have one significant digit, but our final answer has three, so we know it's not that one either. All right, Afia said letter D is the answer. Yes, Malia, this is why we're reviewing. So those reviews are very helpful to go back into what you learned many, many, many weeks ago. If you look at letter C, you have four significant digits. Your final answer also has four significant digits. So that's a possibility, but we always want to double check the other answers as well. So if we look at letter D, we have 12.0, which is three significant digits. But guess what? Our final answer here has two significant digits. That 0 does not count unless there's a decimal present. So this answer is wrong. And in letter E, there are three significant digits here. But in our final answer, we have two. So that's not right. So letter C is the only choice. That's right, Afia. Wait, it can't be D. That's right. It is not D. So letter C is the correct answer. All right. So now, if we go on to the next question, okay, I'm going to clear those answers off. The ideal gas law. Okay, so the person with the white heart, what do you want to know about the ideal gas law? Because today we're doing a review on chemistry, like, general chemistry 1 problems. But what I can tell you really quickly, okay, with the ideal gas law, okay, Afia put in PV equals nRT. Yes, that is correct. So what do you want to know specifically about the ideal gas law? They will give you, out of the 5 variables, they're going to give you 4 of the 5, okay? So 4 out of the 5 variables you'll have to solve the other one. You will normally be given, just as an FYI, they're going to give you your R, which is your rate. Not your rate, your R constant, but your R constant is based on what they give you for your pressure, because there are several different rates that you can use for the R, but it's based on the pressure unit. But tell me what specifically you want to know so I can address it accordingly. Okay, gotcha, Afia. All right, I got you. So as a sidebar, let me put the formula here. We know that the formula is PV equals nRT, right? But suppose we're looking for P. Okay, yes, Malia, I go live Monday through Thursday, 12 noon Eastern Standard Time. I changed my schedule today to go live at 12:15, but I normally go live 12 noon Eastern Standard Time. Yes. So let's suppose that we are trying to look for pressure, okay? I'm going to write everything else in the other color. Because we're looking for pressure, we're going to divide both sides by V. So our formula will become P equals nRT over V. Okay, so that is your one formula that you would need to know for pressure. If we were looking for V, on the other hand, what you would have to do, okay, if you're looking for V, again, using the same formula, PV equals nRT, all you need to do is divide both sides by P now. So I'm going to cross out the P and say V equals nRT over P. So as you can see here, both formulas look to be the same, but they are used for different purposes. So if you're looking for pressure using the ideal gas law, then your formula is going to be P equals nRT over V. But if you're looking for your volume, it's going to be volume equals nRT over P. Screenshot it. Okay. I'll do another formula out of this one so that way you'll know you've got this with the flower plants. You've got it. I'm rooting for you. You're going to pass your Chem 2 final. I know you are. If you're given, again, that same formula, PV equals nRT, but this time, oops, you can't see that part. Let me bring it up like this. There we go. If you're looking for, let's say, your moles, your N are your moles. You're going to divide both sides by the R and the T. And why? Because you're going to get rid of the R and the T. And so your N is going to be equal to P times V over RT. Okay? All right. So now, those are just some quick tips based on using the ideal gas law. Okay? Now, I'm going to go back to my study guide over here so that I can address these questions also, okay? Because remember, today we are going back to the very beginning. We're going back to the basics, okay? So right here for the next one, for number 6, it says the correct answer for the addition of, all right, so I'm going to show you the question. So let me go ahead and zoom out a little bit so you all can see the entire problem. Okay, right here for number 6, you're adding 7.5 plus 2.26 plus 1.311 plus 2. Now, if you're adding all those numbers together, what you have to remember is that the significant digit rule says that when you're adding and subtracting, you always go with the least amount of digits after the decimal. We have 1 here, 2 there, 3 here, and nothing at all for the last one. So therefore, we should not have any numbers after the decimal, and we didn't even have to plug this into our calculator to establish the answer. But just simply knowing, good job, Afia, but just simply knowing the rules, that helps you out. So you do not have to, if you know the rules, you can easily find the answer without having to plug this into the calculator. But if you plug this into the calculator, what you will get is letter A, 13.071. But because we know the rule says we should not have any numbers after the decimal, all of this goes away, all right? That goes away, and our answer just simply becomes 13. However, what if we had 13.5071? then guess what? Our answer will become 14. We'll have to round that off to 14 because that 5 will tell that 3 to go up to a 4. All right. Now, for number 7, this problem requires some extra steps, okay? It requires some extra steps. So what are we going to have to do? We're going to have to read the problem and then do the conversion accordingly. It says, and I know you guys can't see it all. Thank you so much for the roses and the heart puff. Appreciate that. If I can make the little heart. Thank you. All right. So I know you can't see some of the problem, so I'm going to scoot it back a little bit more. All right. So there we are right here. And if you all can't tell, I am under the weather, so that's why I sound a little nasally. I'm under the weather, but the weather ain't got me. I'm going to keep pushing. Hello, Sylvia. Thank you for being in here. All right. So now, if you guys want to go back and review these problems, by all means, you can go to my YouTube channel. That's Learn Chemistry with Professor TK the Chemist, and you'll be able to actually have access to this review. So if you want to go back and look at these review questions, by all means, go back to my review and you'll have them. All right. Now, in this next one, number 7, a dose of aspirin is 5.0 milligrams per kilogram of body weight and has been prescribed to reduce the fever of an infant weighing 8.5 pounds. The number of milligrams of aspirin should be administered is what? So, in a problem like this, one thing you have to know is that 1 gram, I'm sorry, not 1 gram, 1 pound. Oops, there we go. 1 pound equals 453.6 grams. Now, your teachers may not give this to you in your or your cheat sheets or your formula sheets, may not have these basic conversions. If they do not, this is something that I will put on my note cards as a reminder, okay? You've got to know that 1 pound is equal to 453.6 grams. Now, once you do that, I'm going to go up here at the very top and I'm going to rewrite this problem out. So I've got 5.0, or I'm sorry, I'm not going to start with 5.0. I'm going to start with the number that they gave me, which is the 8.5 pounds. Okay? So we've got 8.5 pounds times. What we first need to do is convert that to grams. So 1 pound equals 453.6 grams. And what we're going to do is cross out those like terms that we don't need anymore. Pounds goes away, and pounds goes away as well. Thank you so much. Now, you will also then take your next conversion here, and you'll need to convert that to your milligrams. Now, here's the other thing too. You can actually instead of saying milligrams, you'll convert that to a kilogram. So now your kilogram, I know that 1 kilo is equal to 1,000 milligrams. You're going to go ahead, whoops. I'm sorry, guys. It's equal to 1,000 grams, not milligrams, 1,000 grams. Okay. So now what you're going to do is cross out your grams because you don't need that anymore. So now all you have to do is plug this into your calculator. I'm going to see if I can put a calculator up on the screen here so you all can see me adding the numbers here. Okay. So you've got 8.5 times 453.6, then divide that by 1,000. Whoops, it erased. 8.5 times 453.6, divide that by 1,000. So you get 3.8556, or we could just say 3.9. Now, here's the thing though. you're not done yet, okay? And how we know you're not done? Because you've got to go in and take that number that we get here, all right? We're going to plug that in 8.9 right here, kilograms. Whoops, sorry, you can't see that part. 8.9 kilograms. Now, what are we going to do? We're going to take that 8.9 and multiply that times that conversion factor that they gave us initially of saying 5.0 milligrams per kilogram. We're going to take that number and multiply that, cross out your kilograms, and this is going to give you your answer in milligrams, okay? So all I'm going to do now, why did I say 8.9, y'all? This is what happens when you're not feeling good at all. It's 3.9. Oh my goodness, y'all, I'm sorry. I'm glad I caught it. I'm glad I caught the answer. 3.9. All right, so 3.9 times 5.0 will give you your answer, okay? So if we go back over here and say 3.9 times, and let me show you on the calculator here, times 5.0, we get 19.5. Well, remember, we should not have but only two significant digits, okay? So in this particular case right here, the answer that comes closest to what we're looking for is the 19. So for number 7, the answer is A, all right? The answer is A, 19 milligrams. Okay, 19 milligrams. Now, I'm going to erase all of this because I'm now going to move up to number 8. All right, so for question number 8, this is dealing with density. Now, I remember at the very beginning of the semester, when I did problems like number 8, I made sure to give you all the visual. And I actually have number 8, an example similar to number 8, on my TikTok page also. So let me go ahead and read it out to you so you'll know what we're talking about here. All right, so this question says, a nugget of gold with a mass of 521 grams is added to 50 milliliters of water. So I'm going to go ahead and do the visual for you all. And I'm just going to go ahead and say that you added this nugget to 50 milliliters of water. The water level rises to 77.0 milliliters. 77.0 milliliters. That's what the water level did. It rose. But remember, guys, to get your volume, this is called volume by displacement, you have to say 77.0 minus 50.0 to get the actual amount of water that was displaced. In this case, it was 27.0 milliliters. So what are you going to do? Well, I remember my formula is D equals mass over volume. And since you're looking for the density, you're going to plug in the 521 grams and divide that by 27.0 milliliters. So let's plug this into our calculator. Again, let's pull it up. Okay, so we've got 521 divided by 27.0, and we get, and remember, we got to keep in mind the significant digits rules. We only need 3 of those numbers. So we get 19.3, okay? 19.3 grams per milliliter. So again, let me go ahead and exit out of that calculator so you all can see it. Okay, right here, 19.3. And again, guys, we're looking at number 8 right there, okay? So 19.3 is the answer, letter E. Again, this is dealing with volume by displacement, okay? Volume by displacement, where if they give you 2 volume readings, you must subtract the 2 volumes, which is what I did right here. at this step, okay? So we subtracted the numbers and we got 27.0 milliliters. That is your volume by displacement. The mass that was given was 521 grams. So you divide those two numbers, and that's how you end up with 19.3. All right. Now, in this next problem, we've got, for number 9, it says a urine sample of 50.0 milliliters has a mass of 50.7 grams. The specific gravity of urine is, now here is the deal with this problem. Specific gravity does not have units, okay? It does not have units. Because it doesn't have units, we can cancel out B and A because there are no units involved in specific gravity. However, this problem is solved just like density, where you're going to say mass over volume to do your calculations. And I also know that because I am going to divide these two numbers, the E doesn't make sense either because they're just using the same number that was given in the problem. So I would have to exit that one out. So 50.7 grams divided by 50.0 milliliters. And remember, the units go out. We do not use units here. You are going to do what? Divide those two numbers. 50.7 divided by 50.0 is letter C. Okay, Ophelia, well, not really. So the question that was asked was, do you need a strong foundation in Chem 1 and Chem 2 to take organic? Organic chemistry is indirectly related to those two subjects. You get into more chemical reactions with different isomers and different images like your benzene groups and all those fun drawings that you have to do, similar to what I'm doing here. And you're having to do a lot of memorization. So it's not about a lot of calculations, but more or less drawing the pictures out and having to remember the various chemical reactions and their functional groups. So they're actually different. Yes, Sophia, that is correct. That is correct. All right, if we look at number 10 is now a review on heterogeneous mixtures and homogeneous mixtures. If you can remember, hetero means different, okay? Like boy, girl, up, down, left, right, top, bottom, man, woman, different. Homogeneous, okay, means same. That means girl, girl, boy, boy. But when we also think about homogeneous mixtures, typically in chemistry, that means it has the same consistency throughout. So if I did some salt water, such as what I need for my voice, okay, because I told you guys I'm a little bit under the weather, if I get my salt and add it to my water and shake it up, there's uniformity there. There is the same consistency. In other words, you cannot see the salt dissolving in the water. So when we talk about coins in a piggy bank, we're simply saying what? We know it's not a compound and we know it's not an element. Coins in a piggy bank are an example of a heterogeneous mixture. And why? Because you got quarters, you have dimes, you have nickels, you have pennies. So you have different types of coins in your piggy bank. All right, next problem. Which of the following is not an element? Okay, not an element. So let me scroll the screen up so you all can see that. Right here for number 11. Oops, there we go. Yes, and it's kind of like, there we go. Oh, thank you, Afia. Appreciate you. Appreciate your comments. Thank you so much. And this is why I go live Monday through Thursday every week. I've been doing this entire semester because so many students are concerned about their chemistry grades and they're concerned about asking questions. So I'm just trying to fill in the gaps. I'm a professor also, and because of the way I teach, my students don't have a problem asking me questions. But I know some of you all don't have the luxury of getting a professor like me that takes their time and have patience to answer and address your questions. So unfortunately, because of that, the fortunate part is I actually come in and help you guys. I'm basically, saving the day for many of you guys. So I appreciate that. I will be doing yes, and these problems, thank you guys so much. Nemo, thank you, thank you, thank you. You could get this review on my YouTube channel. So hello, Margarita. Marguerite Jackson, hey, you can get this review on my YouTube channel. So every day that I go live, I actually put these videos. I am simultaneously doing them live on YouTube as well. Yes, yes, yes. Y'all are so sweet and so kind. And this is why I go live every week, because I know even when I'm not feeling well, when I come online, I feel better because I have so many of you all that are supporting me as well. I don't like calling y'all followers. That just sounds so I like saying my supporters. You guys are supporters. All right. So thank you guys so much. Now, if we look at number 11, which of these is not an element? So when I think about an element like tin, what they're giving you, notice the names: tin, water, gold, silver, carbon, right? What you have to remember is that they're giving you the chemical name. You just have to know the chemical formula. All right, so here's what you've got right here. If you look at all of them, the only one that is not an element is water. That is a compound. So for number 11, that is a compound, okay? Number 11 is a compound. Thank you, Afia. See you later, alligator. All right. Number 12. Number 12. Let me scroll that up so you all can see which of the following is a chemical change. Remember, if you cannot revert it back to its original state, that is the idea that you should go by for a chemical change. Melting ice, it can go back, we can freeze it. Hammering gold into foil, we can ball it up. Cutting a tomato, we can just piece it back together. Cutting paper, we can just glue it back together. But burning natural gas cannot go back to its original state. So yes, 12 is A. Very good for those of you guys that put letter A. Very good. Hey, Giselle. Number 13. Which of the following is a property of both liquids and gases? All right, you got to know what properties are for liquids and gases. If I spill my tea, spill my water, it's just going to go and disperse in its own direction, wherever it wants to go. If I spray some gas, it's going to disperse anywhere it wants to go. So in other words, letter D is the answer. We can't say that they have its own shape because they do not. Liquids and gases, they basically, liquids take the shape of the container, but gases get dispersed throughout. Gases do not have a definite volume, nor do liquids. So when you think about the rules of what you know about liquids and gases, just remember that they are randomly arranged particles, okay? They have their own mind. They go any which way they want. Number 14, you would have to know the formula for finding degrees in Fahrenheit, okay? So if you're trying to find the temperature in Fahrenheit, it's 1.8 times degrees Celsius plus 32. So what are you going to do? You're going to take the 1.8 times 20 degrees. Do that first. Then add 32 to your value. Kanan, I don't know what you're talking about. Okay, I do not know what you are talking about. All right, so let's see if we can get this answer right here. Okay, so let's bring up in my Blues Clues days when my kids were little, they loved Blues Clues. Okay, Gannon, listen. 1.8 times 20 plus 32 gives us 68. Okay, so 68 is the answer for number 14. So B is the answer. So those of you all that got that, you are correct. 68. Number 15. You have to do what? For 15, you have to just know it. All right. Absolute zero is the coldest temperature possible. All right. That's just one of those things that you read in a chemistry book and keep it pushing. All right. For number 15. So I won't take a lot of time addressing that one. Okay. Now, number 16. Number 16. This one requires a little more in-depth information. So I'm going to go out a little bit so y'all can see the screen. Okay. And because this is one that even though it's a lot of reading to it, you've got to still do what? You've got to still read the problem and don't think that because it's so long that it's going to take you a long time to do it. It is not. So for number 16, it says a cheeseburger, and it is lunchtime, from a fast food restaurant contains 19 grams of fat, 20 grams of carbs, and 28 grams of protein. How many kilocalories of food does that cheeseburger contain? The caloric values are 4 kilocalories per gram for carbs, 9 kilocalories for fat, and 4 kilocalories per gram for protein. So for this particular problem, I know there's a lot of information here, but let me tell you, it's not that bad. So let me show you all the easiest way to do it. For the fat, we're going to say 19 grams times, and find the one for fat, which is 9 kilocalories. Divide that over the 1 gram. Cancel, cancel. I'm going to give you all the numbers for those in a second. For your carbs, you had 20 grams of carbs times for 4 kilocalories. Right there, you're going to put 4 kilocalories per gram. Cancel out your grams. And then for the last one, for your protein, you've got 28 grams of protein times, and for your proteins here is 4. The conversion is 4. I put the wrong thing for carbs, guys. Oops, sorry. That should be 9 for that one. My bad. For the carbs, that was 9. For your protein, that was 4. Again, divide that by 1 gram. So all you have to do now is just go through and multiply each of those numbers, okay? Just multiply each of your numbers to get your answer. So for the fat, when you got 19 times 9, okay? Let's look up our calculator. 19 times 9, you get 171 right here. For the carbs, you've got 180. And for your protein, that's 28 times 4. Let's see what that's equal to. 28 times 4. That's equal to 112. Hold on, y'all is telling me something. Hold on, y'all. Wait a minute. Let me see. Okay, you all said it's 4 for the carbs. Oh, gosh. Yes. Thank y'all. Yes. Appreciate y'all for stepping in to see the mistake. Let me put that number here. For the fat, it is 9. That one is right. For the carbs, it is 4. Let me put the right answer for that one, which is 80. For the protein, it is also 4. Yeah, there we go. It is also 4 for the protein. Okay, so we got that corrected. Thank you guys. Appreciate you all. So what you're gonna do, let me do the correct math. 28 times 4, we get 112. So yes, this one was 112. So what you're gonna have to do now is go in and add all those together. 112 plus 80 plus 171, and we get 363. Okay, 363. But now remember, for this particular problem, even though when we add all those together and we get 363, it says round off the energy value to the tens place. So this becomes 360 kilocalories. So letter B for that one. Okay, letter B for that one. All right. And for number 17. Number 17, I know it's kind of split. It's like a split screen there. It says how many calories are required to raise the temperature of a 35.0 gram sample of iron from 25 degrees to 35 degrees Celsius. Oh, thank you, Nemo. Iron has a specific heat of 0.108 calories per gram degrees Celsius. All right, what you've got to remember for this particular equation is the right formula, okay? If you don't have the right formula for the problem, you will get this one wrong. So I'm just going to remind you guys that whenever you're doing a problem like this, let me give you all the formula in case you forgot. And again, this is for specific heat. All right, guys. So for specific heat, the formula, in case you guys forgot, I'm going to write it on the screen, and you all can, again, screenshot it so that way you will know what the formula is for it, okay? So for specific heat, and you can also say calories as well, okay? So if specific heat is equal to your heat divided by your mass times your delta T. Remember, your heat part up here, that can also mean calories, okay? You can say basically joules, which means calories, all right? But in this case, you're looking for the calories. You're looking for the top number. So what we're going to do, we're going to say, all right, well, because we want to find our heat or our calories, we're going to say the specific heat times the mass times the delta T. Yes, Alex, this is on my YouTube right now. Click that link in my bio. It is Learn Chemistry with Professor TK the Chemist. You don't need to turn the temperature to Kelvin, no. So all you're going to do is plug in the specific heat number right here, which is 0.108 calories per gram degrees Celsius, times the mass that they gave us here was 35 grams. So 35.0 grams. And let me make that 35, that 3 look like a 3. Whoops, still didn't do it right. Times. Now your delta T is basically the final temperature minus the initial temperature. Well, they told us 25 degrees to 35 degrees. So you're going to say 35 degrees Celsius minus 25 degrees Celsius. That's equal to 10 degrees Celsius right here. Okay? So you're going to put the 10 degrees Celsius right there. Now, all you're going to do is cancel out your like terms. So your grams are going to go away, your degrees Celsius is going to go away, and now all you're left with are your calories. So plug this into your calculator, and here we are again, 0.108 times 35 times 10, and that gives us 37.8. Well, remember, we only need two significant digits. So 37.8 becomes 38 calories. Letter A is our answer right there. Okay, 38 is our answer. All right. So I'll go ahead and do number 18. We'll close it out with number 18. Okay. And then when we come back tomorrow, because again, remember, we're spending a little bit of time doing each of these problems each day. Because I want to make sure I also dedicate time to my general Chem 2 students also, because I know they need help as well. So I'm trying to go back and forth between each, level of chemistry. So I may have to put a schedule up where I am going to I may go live in the evening time. I don't know, don't hold me to it. But what I may have to do is like go live basically Monday, Wednesday, maybe General Chem 1, and Tuesday, Thursday, maybe General Chem 2. I don't know. We'll have to see. Okay. Wherever the most attention is needed, that's where I'll go. So for this last problem, number 18, I'm going to do that one, okay? It says the specific heat of copper is 0.0920 calories per gram degree Celsius. The specific heat of silver is 0.0562 calories per gram degree Celsius. If 100 calories of heat is added to 1 gram of each metal at 25 degrees, what is the expected result? All right, so let me show you all how to do this, okay? You're basically looking for, so again, let me give you all the formula once more. Specific heat, if we know that this was the formula right here, okay? If this was our formula right here, and they gave us a specific heat, they gave us the joules, which is calories also, and they gave us the mass. They did not tell you the complete total change in temperature, but what you could do is rearrange this formula to find your delta T, okay? Or at least a change in temperature. So the formula is going to basically become your joules over your mass times your delta T, times your, not delta T, guys, times your specific heat. So again, let me say it again so y'all can hear me. You're looking for the change in temperature. So it's going to be your calories on the top divided by your mass times your specific heat. So what I'm going to do for the first one, I'm going to put it up here so you all can see that. I'm going to have to write really small. So I'm going to work it out over here. Well, I could probably do it over here in this little space as well. But I'm just going to put it right here so you guys will know, okay? For the first one that we're doing, we're going to do silver, okay? We're going to do silver. So I'm going to say the calories they gave me was 100. That's on the top. On the very bottom, the mass they told us was 1 gram each. They also gave us the specific heat for silver, which was 0.0562 calories over grams degrees Celsius. Okay, what you're going to realize here is that when we plug this into our calculator, okay, remember, your units are going to cross out, your grams are going to cross out, your calories are going to cross out. So your degrees Celsius is going to be there. So when we plug this into our calculator, okay, we're going to say 100 divided by 0.0562, and we get 1,179. All right, so that's Silver's number. Ag is equal to 1,779 degrees Celsius. So we're going to put that there, okay? I'm going to do the copper one. So copper, same thing. Let me erase some of these formulas here that we don't need, okay? For copper, Cu is going to be equal to the same thing. 100 calories over 1 gram times. Now I'm going to use copper's number. That's 0.0920 calories per gram degrees Celsius. So again, you're going to cross out your grams, cross out your calories, and you're left with degrees Celsius. So we're going to plug this into our calculator again. 100 divided by 0.0920, and this tells us 1,087 degrees Celsius. So if we go to our question, okay, and we go to our answers, it says, what is the expected result? Is it A, the copper will reach a higher temperature? And this is copper's results right here. So I'm going to highlight that in yellow so you all can see it, okay? This is copper's number right here. So is it A, the copper will reach a higher temperature? Or is it B, the silver will reach a higher temperature? Or C, the two samples will reach the same temperature, meaning they're both equal? Or D, the copper will reach a temperature lower than 25 degrees Celsius? Or E, the silver will soften? Well, in this case, if I look at my results here, I know that it's B. The silver will reach a higher temperature. So that is my answer for that particular problem. All right, guys. So this is the point now where we will stop. We will end our review for today, but we will go back over some additional problems throughout the week that deals with, of course, trends of the periodic table, protons, electrons, and neutrons, because we've got to get that in. We're going to also go over nuclear chemistry, because that's a part of your exam too. So there's some nuclear chemistry problems, radiation, and we'll get into stoichiometry as well. Okay? So we're going to come back and do these reviews tomorrow. If you all have questions that you want me to go through during the review, during the live, make sure you go back to my last video and type your comment under that, and I can address that. If I don't get a chance to get to it, please don't charge that to my heart, but instead make sure that you all know I have 1,000 different DMs and people that have asked me to do questions for them before. So you might be in line, or your question may happen to come up. Okay, so I appreciate you guys so much, and I look forward to seeing you all once again tomorrow. Don't be surprised if I hop back on tonight. I don't know. I'm just saying, I just might. All right, guys, so you all have a good one, and I will see you all tomorrow. Take care.